We will be discussing operational amplifier as a summing amplifier. In this lecture, we will be discussing operational amplifier as summing amplifier, summing amplifier, or operational amplifier as summer. Okay, this is a simple word for that. So, or operational amplifier as adder, or adder summer, or summing amplifier. That is one and the same thing. So I'll draw first operational amplifier here. So this is an operational amplifier. You have inverting terminal, then you have non-inverting terminal, then you have output terminal. Okay. Of course, we have plus VCC and then we have minus VEE. These are the biasing terminals. Then in this amplifier, in this circuit, non-inverting terminal is grounded and part of output is given back to input. So in this way, we will have a negative feedback. Okay, so we'll have a negative feedback here. So this is feedback resistor RF. Apart from feedback resistor, there is input also. Okay, so there is input V1. V1 is the input, and you have resistor R. Since V1 is applied, since the input is applied at inverting terminal, please note my words. Since the input is applied at inverting terminal, therefore the amplifier will be known as inverting amplifier. Okay, so it is basically inverting type in it is basically inverting summing amplifier. Why it is inverting summing amplifier? It is summing amplifier because it sums different inputs. Why it is inverting type? Because the input is applied at inverting terminal. Okay, it is applied at inverting terminal. You should note it. Whenever the input is applied at inverting terminal, you should always remember that circuit is inverting type. So we have one input here. Another input is also here. So we have another input which is V2. This is also R. Then we have a third input which is V3, and it is also applied to R. Okay, so we have three inputs, V1, V2, and V3. I'll write down here V1, V2, and V3 in the circuit. They are all inputs. They are all inputs to the circuit. Okay, then we also have node A, that is here. Then we have node B, that is here. Whatever voltage here at node A you will be having, it is V of A. Whatever node voltage is present at B, it is V of B. Okay, V of B. So if I will ask someone, what is V of A equal to? Shahab, what is V of A equal to? Shahab, what is V of A equal to? Shahab is here. 59. Roll number 59, please turn on your mic.
Yes, sir.
आप कहाँ गए थे? What is
Sir,
V of
इधर ही
A?
हूँ.
What is V of A equal to?
Sir, I don't remember right now.
You don't remember? You can see from the circuit. There is nothing to remember in it. You are at your home or you are outside your home?
Sir, I'm not at my home right now. मैं
Okay.
पुफी के घर पे.
Where is Fatik? Fatik is here. Fatik. Fatik. Shazia, roll number 2. Shazia. Roll number 2. Shazia. Roll number 3. Roll number 3.
Sir,
What is VA equal to? From the circuit you can see. You have to remember that we have virtual short circuit approximation and virtual ground approximation. What will be VA equal to?
I don't know.
You don't know? Can you guess anything from the circuit?
No, sir.
Okay. Pradeep है यहाँ पे. Pradeep 61.
Yes, sir.
What is VA equal to from the circuit? Can you identify from the circuit? Can you guess what is VA equal to? Assuming a virtual short circuit and virtual ground approximation.
No, sir.
No one? Okay. Anyone? Can anybody guess what is VA equal to? If anybody knows, please write down in the chat section or you can raise your hand also. किसी को पता है? Saeed Tahir. Yes, Saeed Tahir.
ये V naught into R divided by R plus R है.
VA Saeed Tahir. Manjeet. Yes, Manjeet. आप बताओ.
V naught into R
V naught into R.
divided by R plus R है.
R plus RF. What about Saeed Tahir? Saeed Tahir है यहाँ पे. Saeed Tahir
Yes, sir.
ने
Yes, sir.
what is VA equal to?
सर ये ठीक है V out into R divided by R plus RF.
That is incorrect answer. It is very it is quite away from the correct one. If you notice from the circuit VB, what is VB? Saeed Tahir, VB, what is VB equal to?
Sir, VA is 0.
VB is equal to 0 and VA is also 0 because there is a virtual short circuit between VA and VB. So VA is equal to 0 volts. VA is equal to 0 volts. Now see, if we apply KCL at node A, if we apply KCL at node A, we can then calculate the currents. What are the currents coming to node A? See, there are basically 4 currents. One current is here, I of F. There is another current, I1. Another current is there, I2. A fourth current is there, I3. Okay. So if we apply KCL at node A, we will see that IF plus I1 plus I2 plus I3, they all will be equal to 0. Okay. They all will be equal to 0. And what is I1? What is first of all IF? IF is equal to V output minus VA divided by R of F. What is I1? I1 is equal to V1 minus VA divided by R. What is V2? I2? I2 is V2 minus VA divided by R plus V3. I3 is equal to V3 minus VA divided by R. This will be all equal to 0. And we know VA is equal to 0. VA is equal to 0. We can simply write it down that V1 divided by R plus V2 divided by R plus V3 divided by R plus V output divided by R of F. This is all equal to 0. And we can then rearrange the terms. We can take V output on one side, rest all other terms on another side, and we can write down V output is equal to minus RF into V1 plus V2 plus V3 all divided by R because they have a common denominator R. Or we can say V output is equal to minus R of F divided by R into V1 plus V2 plus V3. V1 plus V2 plus V3. Now see, if you understand this equation here, if you try to think over it, you will be able to find that this circuit basically sums up all different inputs. It sums up all different inputs. What are different inputs? V1 plus V2 plus V3 plus V1, V2, and V3 are all inputs. Okay. So here I have already mentioned here V1, V2, and V3 are all inputs. It sums up all inputs. Then it amplifies. Okay. If we compare this equation, say for example, this is equation 1. The general equation of an amplifier is V output is equal to gain times V input. Say for example, this is equation 2. If we compare equation 1 and equation 2, we will be able to find out gain, uh, which is basically closed loop gain, ACL of the circuit is equal to minus RF by R, and we will be able to find V input is basically equal to V1 plus V2 plus V3. That means this circuit, first it sums all the analog inputs together, then it amplifies. What is the amplification? It is minus RF by R. Amplification is minus RF by R. Amplification is minus RF by R. So closed loop gain here, it is minus RF by R, minus RF by R. If I will ask someone, what should be the phase difference between input and output? Manjeet, what should be the phase difference between input and output of this circuit, given that output equation is this one? Manjeet,
Yes, sir.
what should be the phase difference between input and output? You have a negative sign in the equation.
सर 180 होगा फिर जब नेगेटिव साइन.
हाँ बिल्कुल, the phase difference, very good. Phase difference here between input and output will be equal to 180 degree. Why? Because you have a negative sign. Okay, you have a negative sign. Whenever you have a negative sign in the equation, it means phase is inverted. Phase is opposite. So phase is opposite. Phase is opposite. So please remember, this is a very special amplifier. It is known as summing amplifier, and it is also inverting. Inverting means because it provides a phase shift between input and output equal to 180. It is inverting because input is applied at inverting terminal. And it is summing amplifier because it sums all inputs together, then it amplifies. Okay, so we can write down concluding remarks, summary on it. Circuit performs summation of three input signals, okay, and comma amplifies them, amplifies the sum, by which factor? By a factor of RF by R. So neglecting the negative sign, okay, by a factor of RF by R, and provides a phase shift of 180 degree. Provides a phase shift of 180 degree. Okay. Now there is a special case in this circuit would be if RF is equal to R. If RF is equal to R, see we have RF here, okay? We have RF here. If this RF is equal to value of R, if RF is equal to value of R from equation 1, if RF is equal to R from equation 1, from equation 1 we have, then what will be the output? V output will be equal to minus times V1 plus V2 plus V3. So it is a special case. If RF is equal to R, then your output will be simply equal to summation of all these inputs minus times. That means it should be, it will be out of phase. It will be out of phase. Okay. So this is known as adder. This is known as adder using operational amplifier. But please remember that this is inverting type summing amplifier, inverting type adder, inverting type adder. This is not non-inverting type. So I will now demonstrate this is inverting type. I will demonstrate now. I'll show you non-inverting type. Summer. Non-inverting summing amplifier. Non-inverting summing amplifier. You see, like inverting summing amplifier, inverting summing amplifier, you have optical, then you have a negative feedback, then you have deployed in similar fashion. So this is operational amplifier. You have inverting terminal, you have non-inverting terminal, then you have V output, okay? Then you have a feedback resistor. Feedback resistor. You have अपनी mic बंद करो. 62, roll number 62.
Yes, sir.
Where should be the feedback present if we are studying
Sir, with
negative
non-inverting terminal.
non-inverting terminal?
Yes, sir.
You mean like this? Negative feedback. This is a negative feedback.
Sir, ये inverting terminal. Sorry,
Inverting.
sir.
ये inverting है?
सर जो ऊपर नेगेटिव जो ऊपर दिया हुआ है.
ठीक है. So the feedback should be between output and inverting terminal. Then it will be called as negative feedback. You can turn off your mic. Now see, we'll complete the circuit now. There will be also a resistor here R. In the previous circuit, we had grounded non-inverting terminal, but here we will ground inverting terminal. Please compare it with this circuit. Okay, please compare it with this circuit. So the input was applied in previous circuit to inverting terminal, but here input will be applied to non-inverting terminal. Okay, input will be applied to non-inverting terminal. So you have three inputs, V1, V2, V3. This is R, this is also R. Okay, so this is now non-inverting type summing amplifier. Why? Because input is applied at non-inverting terminal. Please note my words, what I am saying. This is a non-inverting type summing amplifier. The previous example was inverting type summing amplifier. Why? Because there the input was at inverting terminal. But this one is a different one. So this will be current I1, this will be current I2, this will be current I3. Okay. And we have node A here, then we have node B here. Okay. We have node A, we have node B. Now see, if we apply KCL at node B, what we will be able to find, we'll be able to find I1 plus I2 plus I3. This is all equal to 0. So what is I1? I1 is V1 minus VB divided by R plus V2. I2 is V2 minus VB divided by R. I3 is V3 minus VB divided by R. This is all equal to 0. This is all equal to 0. Okay. Now VB here, VB here in this circuit, VB is equal to 0. Okay. VB is equal to 0. Here VB is equal to 0. VB is equal to 0. Just a second. Okay, first of all, let us try to find out VA. What is VA here? VA is basically output voltage of a voltage divider network. Okay. VA here is equal to output voltage of a voltage divider network. So what is voltage divider network in this circuit? Whatever is being highlighted using yellow line, that is a voltage divider network. Okay. So in this circuit, VA, basically VA is equal to V output into R divided by R plus RF. Okay, so this is output of a voltage divider network. Voltage divider network. Okay, so if we try to find out V output from this, V output here from this equation, V output will be equal to VA into R plus RF divided by R plus RF divided by R. So what is V output? V output here, it is equal to VA into 1 plus RF divided by R. 1 plus RF divided by R. Okay. Now see, what is VB now here? VB here, what is VB here? VA is basically equal to VB, because if we assuming virtual short circuit in the circuit given, okay, if we assume that there is a virtual short circuit, then we know VA is equal to VB. VA is equal to VB. मंजीत बेटा आपको ये समझ में आ रहा है मैं क्या लिख रहा हूँ? मंजीत,
जी सर आ रहा है।
is it difficult?
नो सर।
Okay, सैयद ताहिर, आपको बेटा,
Yes, sir.
हाँ, do you have any question?
No, sir.
आपको ये समझ में आ रहा है बेटा?
Yes, sir.
Okay, all right. So VA is equal to VB. ठीक है? Virtual short circuit, but VA is present here. So therefore we can write down. Therefore we can write V output will be equal to, let this is equation 1. Therefore we can write from equation 1. Equation 1 को हम लिख सकते हैं, instead of VA we'll write down VB into 1 plus RF divided by R. Okay, RF divided by R. Now the question is, what is VB now? VB is not surely 0. VB is not surely 0. This is equation 2. So say for example, this is equation A. Here, this is equation A. So we can write down from equation A, we can write down, the equation is like this. See, it is equal to V1 divided by R minus VB divided by R plus V2 divided by R minus VB divided by R plus V3 divided by R minus VB divided by R. This is equal to 0. Okay, so I have expanded equation A now. I have expanded equation A now. So I can write down this V1 divided by R plus V2 divided by R plus V3 divided by R minus, so you have three terms. One is VB by R, this is VB by R, this is also VB by R. So I can write down minus 3 times VB by R, because there are three terms. Okay, there are three terms. If I will take 3 VB by R on right hand side, we will be able to find V1 plus V2 plus V3 divided by R is equal to 3 times VB by R. Okay, now see, you have R on this side in the denominator, you have R here also in the denominator. They will be cancelled out. If you will find now VB, what is VB? VB will be equal to V1 plus V2 plus V3 divided by 3. Okay, this is all VB. Say for example, this is equation 3. Now, using equation 3 in equation 2nd, if we substitute equation 3 in equation 2nd, we'll be able to find out V output is equal to, instead of VB, we will write down V1 plus V2 plus V3 divided by 3. Okay, then you have another term. Another term is 1 plus RF divided by R. 1 plus RF divided by R. 1 plus RF divided by R. So this is your output. This is my output. Okay. This is my output. And 1 plus RF by R is my gain. 1 plus RF by R is my gain. 1 plus RF by R is the closed loop gain of this amplifier. It is the closed loop gain of this amplifier. 1 plus RF by R. Okay. Now see, there is a special case in this equation. Special case in this equation. If R of F is equal to twice R in equation 4, if R of F is equal to twice R, then what is V output equal to? Then V output is equal to 1 plus twice R, okay, twice R divided by, sorry,
सर
you-
सर
जी
2R divided by R कैंसिल हो जाएगा सर, बचेगा 2
हाँ, you just hold on. So this is what we will be having, okay? Then we have V1 plus V2 plus V3 divided by 3, okay? So we can further simplify it. It will be 1 plus 2, R and R, as correctly said by someone, it is equal, they will be cancelled. Then we will have V1 plus V2 plus V3 divided by 3. So 1 plus 2 is also 3, and you have something in denominator which is 3. So your V output will be finally equal to V1 plus V2 plus V3. Okay. Please note that in this equation, final equation, there is no negative sign. Okay. Therefore, phase difference between input and output, it is equal to 0 degree. So there will be no phase shift between input and output. That is why this amplifier, or this summing amplifier, is known as non-inverting. It is known as non-inverting. Why? Because there is no phase shift between input and output. Okay, there is no phase shift between input and output. That is why this amplifier is known as non-inverting summing amplifier. So please note this thing. Our amplifiers can be inverting or it can be non-inverting type, depending upon where the input is applied, depending upon where do we apply the input, okay? So accordingly, our amplifiers could be either inverting type or it could be non-inverting type. So in examination also, the questions could be inverting type or even in non-inverting type. We don't know what will be the question, but you have to be careful. You should be able to solve any question very easily. Okay. So this is amplifier, summing amplifier. It is also known as adder. What is the job of adder? It simply adds up all input signals and then amplifies them. All input analog signals are being added up, then they are being amplified. There is another. Yes, if you have any question, किसी को कोई सवाल पूछना है?
इक्वल टू 2R कब होगा सर?
हाँ,
RF is equal to 2R कब होगा सर?
ये जब आप चाहो, because all these resistances, they are chosen by the user. These resistances, the value of all these resistances, it is upon the designer. When you assemble the circuit, then it is up to you what should be the value of R. Sometimes you can keep RF equal to R. Sometimes you can keep RF equal to twice R. It is not necessary. There is no problem in that. तो जब आप चाहो RF को twice R बना सकते हो, जब आप चाहो नहीं बना सकते हो. ये सिर्फ यूजर तक है. जब वो बनाता है सर्किट, what should be the circuit, ठीक है? What should be the circuit, वो उसी तक है. इसमें हमारा कोई रोल नहीं होता है, मतलब इट्स नॉट समथिंग ऑटोमेटिक, या कोई ऐसा नहीं है कि डिपेंड्स अपॉन सर्टेन फ्रीक्वेंसी और सम अदर पैरामीटर, but it depends upon the designer. Whenever he assembles the circuit, it depends upon him what is the value he has chosen for the resistor. He can choose RF equal to R, he can choose RF equal to twice R, he can choose RF equal to 1/2 of R. So the next example is difference amplifier. The next example is difference amplifier. Difference amplifier. This is also known as, previous circuit was adder. This is known as subtractor. Subtractor using operational amplifier. Subtractor using operational amplifier. Okay. So I will draw first of all the circuit diagram. Since it is using operational amplifier, so this is all using operational amplifier. There will be output, there will be inverting and non-inverting input. Upper one is inverting input, the lower one is non-inverting input. And since it is an example of negative feedback, there will be a negative feedback between output, connection between output and inverting input using resistor RF. Say for example, RF is equal to R2. It is just an example. And there is an input which is applied here through R1. So there is an input which is known as V2. Another input is applied here, which is R1 here also, which is V1. Okay. Suppose you have the circuit like this. This is R2. Now see, you have two nodes here. Upper one is node A. This is node B. You have VA and you have VB. Okay. And there are two inputs. There is no differentiation here, in this circuit, whether it is inverting or non-inverting, because input is applied at both inverting and non-inverting terminal. Okay. Obviously, it will be inverting or non-inverting depending upon the strength of signal, which input is more. Okay. कौन सा dominating होगा वो मैं बाद में बताऊंगा. But this is how the circuit would be. Now see, in this circuit, if we will try to find out what is VB, okay, what is the voltage at node B? Voltage at node B is output of a voltage divider network. Output of a voltage divider network. Which voltage divider network? This is the voltage divider network. Okay, this is the voltage divider network. So this is a voltage divider network. Here, the voltage will be equal to output voltage of a voltage divider network, which we know VB will be equal to V1 into R2 divided by R1 plus R2. Okay, so this is output of a voltage divider network. Voltage divider network. Okay, and please remember that for calculation of VB, it is a special case. Oh, sorry, VA. What is VA now? VA. How do we calculate VA? VA will be equal to VA. Can somebody help me in calculating VA? VA has this branch. Okay, this is the branch of VA. And there are two inputs applied, one here, another here. Can somebody help me? How can we calculate? Shahab? Shahab is here. Sayyid Tahir?
Yes, sir.
कैसे करेंगे बेटा इसमें कैलकुलेट VA?
सर अगर नोड लगाएंगे सर.
कहाँ पे नोड लगाएंगे?
यहाँ V is good. यहाँ पे सर.
कहाँ पे? Can somebody give me an idea how can we calculate VA in this branch?
Yes, sir.
KCL. Sir, KCL में.
आसिफ मुश्तबा.
V2 minus, sir, V2 minus V naught
Okay.
into RF divided by R1 plus R2.
Okay, just a second. You are saying V2 minus VA?
Sir, V2 minus V naught
V naught
is into R2 divided by R1 plus R2.
divided by R1 plus R2. Oh. Okay, that is one opinion. What is the next opinion? Umar Bashir, what is the next opinion?
VB के बराबर होगा ना सर ये हमने पिछली बार
VB. हाँ, VB तो ये तो पता है. VA will be surely equal to VB, but VA will be equal to VB. Why? Because of virtual short circuit approximation. But what is VA equal to in terms of V output and V2, वो तो पता है VB के बराबर होगा, लेकिन in terms of V output and V2 वो किसके बराबर होगा? Anybody किसी को कोई आइडिया है?
सर VA upon V2 upon R1 plus
VA upon
VA minus V
VA
सर
upon
VA minus V2
VA minus V2
upon R1
अच्छा
plus VA minus V0 upon R2 equal to 0 सर
VA
KCL
minus V0 divided by
R2
RA तो वहां से
equal
करंट
to
निकलेगी,
0
वोल्टेज बाय रेजिस्टेंस इज
V2
करंट।
plus V0
जस्ट अ सेकंड, वोल्टेज बाय रेजिस्टेंस इज करंट, तो हमें करंट मिलेगी। आई एम कैलकुलेटिंग वोल्टेज, वी आउटपुट वोल्टेज, आई एम कैलकुलेटिंग वोल्टेज नॉट करंट। आतिफा, रोल नंबर 27 इज हियर।
अस्सलाम वालेकुम सर।
वालेकुम सलाम बेटा, कोई आइडिया है?
सर सर करंट लिख सकते हैं ना V2 minus V0 upon R1 plus
Zakir, just a second, let me ask someone else. I will come to you. Atifa, yes, do you have any idea? Okay, जिसको पूछा जाता है सवाल, he leaves the meeting immediately.
sir
Roll
V2
number,
plus V0
just a second. 39, yes, V2
plus V0
plus V0
into R1 divided by R1 plus RF
into R1
divided by R1 plus RF.
R1 plus RF. What is your name?
Sir Mohammed Shahid Rishi.
Okay, Mohammed Shahid. This is another opinion. So we have three opinions now. Second one is not, it is far. Roll number 41 is here. 41.
Yes, sir.
जी, आपका कोई idea है? Do you have any idea? Let me make this problem first simple, okay, for you. So the circuit is like this. This is V of A. This is V output, and this is V2. Okay, so you have R of F at the top and R1 here. I just want to find out V of A. 41
सर इसको तो सीधे फिर वोल्टेज डिवाइडर फॉर्मूला ही अप्लाई करनी है ना?
कैसे? हाँ वो बताइए, वोल्टेज डिवाइडर ही होगा, बट हाउ कैन वी अप्लाई? जस्ट
सर
गिव मी एनी आइडिया। हाँ, यू आर हाफ करेक्ट, प्लीज एक्सप्लेन इट।
सर टोटल वोल्टेज इनटू आरएफ डिवाइडेड बाय R1 प्लस RF, मगर टोटल वोल्टेज क्या लेंगे वहां पे?
व्हाट इज द टोटल वोल्टेज? दैट इज द क्वेश्चन, गोल्डन क्वेश्चन इन दिस
V2 plus V0.
V2 plus V0 तो इसने कहा, so that is one opinion. 1, 2 and 3, opinion number 3. Okay, let me ask someone else. Fatik is here, roll number 57. Fatik,
यस सर।
हाँ बट कुछ आइडिया है बेटा?
सर यही सर V2 प्लस V0 सर। गेन का इसमें तो कुछ यूज नहीं होगा सर?
गेन तो एम्पलीफायर में होता है, वो बाद में होगा। एट द एंड व्हेन यू विल फॉर्मुलेट एंटायर इक्वेशन, देन यू कैन डिफाइन गेन। अभी तो इसमें गेन का कोई इशू नहीं है, बिकॉज इट इज just two resistors connected in series, and there are two different sources, and then you want to connect the output, you want to calculate the output.
जी नहीं सर, नो आइडिया।
No idea? Okay. Mehreen Mushtaq 54.
यस सर।
हाँ बताओ बेटा, कुछ आइडिया है?
सर V2 plus V0
Okay. Opinion number 3.
into R1 R2 divided by R1 plus RF.
Into R1 R2. Okay, let me rewrite it somewhere else. So you mean to say you have a different opinion now? It is V2 plus V0 into R1 R2, ऐसे divided by
R1 plus R2.
RF. That is what you were saying. Okay. Nadia 70.
Yes sir.
What is your opinion? keep your mic on, otherwise I'll remove you. अपनी mic on रखें.
Yes, sir.
What is your opinion? Which one is correct? Or
Sir,
you have a
पता
different?
नहीं.
So you don't know. Kazi Maria,
Yes, sir.
what is your opinion? What should be the output?
Sir, I don't know.
You don't know.
Sir, it should be V2 minus V naught into RF divided by R1 plus RF
V2 minus V naught divided by
into RF. Sir, into
into
RF R1 plus RF.
R plus RF. ओके, ये हालत बहुत खराब है. चलिए ठीक है, मैं और एक सिंप्लीफिकेशन करता हूँ. ओके, आई विल जस्ट सिंप्लीफाई दिस सर्किट नाउ. मे बी somebody can answer it now. This is basically this circuit. V output, and I have this circuit. You have V2 here. This is just a second. RF. This is R1, and I want to calculate VA, which is here. Can now somebody tell me what is the way I can find out in this circuit the output? VA is the output.
सर ये भी आ सकता है ना सर, और
मंजीत, अब देखो मंजीत, सर्किट पे देखो एक बार, then please try to give your opinion. You can do it. I think it is very easy now.
सर R1 into
R1 into
V naught
no.
minus
See,
V2.
I have a circuit now. I have a circuit. It has many sources inside. How do you find out the net effect at a node due to many sources? Have you heard principle of superposition theorem? अभी पढ़ा है? सुपरपोजिशन में क्या करते हैं हम?
Sir, at the time one source लेंगे sir.
At a time एक ही सोर्स लेंगे, एक को बिल्कुल शॉर्ट करेंगे. That is a very simple answer. ठीक है? At a time एक सोर्स को लेंगे, दूसरे को शॉर्ट करेंगे. So if we will short it like this, only V naught will be there. So let me now make it simple. Okay? अब इसको मैं ऐसे करूंगा. हम इसको all these your opinions, let me delete them. See what I have now. So I have a circuit in this fashion. I will make two circuits out of it. One circuit is this. This is VA1, this is V0, this is RF, this is R1. Another circuit is this one. Now see, VA is equal to VA1 plus VA2. अब आप देखिए, we are just trying to apply superposition theorem. Okay, so it is by superposition theorem. What I am trying to do, I am separating these two voltage sources. When you have many voltage sources in a branch, how do we solve it? We solve it very easily by superposition theorem. We remove all sources, just keep one, then try to find out the effect. Then we remove that source, put another one, then find out the effect at a node, then combine these two sources, combine these two effects together. Okay, so maybe somebody can help me now.
Individually करना है ना?
Yes.
Individually.
Fatik, yes, please repeat what you are saying.
सर ये पहले individually करना है ना?
Individually करना है. That is not a big deal. So what is the output of this blue circuit? Fatik, can you help me? What is the output of this blue circuit? VA1 will be equal to?
Sir, Sir, VA1.
VA1 will be equal
divided by R1 plus RF.
Divided by R1 plus RF. What about V2? Junaid Shah, roll number 46, VA2. Junaid Shah, 46.
Yes, sir.
ठीक है, बताओ बेटा, what is VA2 equal to now? What is VA2? Keep your mic on, otherwise I'll remove you. what is VA2 equal to now? Okay, turn off your mic. Taiba Iqbal, 75.
Yes, sir.
What is VA2 equal to? VA2 equal to, what is VA2? Plan 66. Plan 66. तैयबा आप अपना माइक बंद करो. Zahid Mushtaq, 64. Misbah Manzoor, 63.
Yes, sir.
Yes, what is VA2 equal to?
So 0 into R1 divided by R1 plus RF.
0 into R1?
0 into R1.
0 into R1 means 0.
Yes, sir.
So it will be 0. Danish Imtiaz. Danish Imtiaz. Shahab Latif.
V2 into RF divided by R1 plus RF.
V2 into RF divided by R1 plus RF. Okay. Now see, we can write down now what is VA equal to. VA is equal to VA1 plus VA2. That is equal to V output into R1 plus V2 into R of F. And both of them, they have a common denominator. What is the common denominator? R1 plus RF. And if RF is equal to R2, then you will be having V0 into R1 plus V2 into R2 divided by R1 plus R2 if R of F is equal to R of 2. If R of F is equal to R of 2. So that is VA. Okay. Now we can now say due to virtual short circuit approximation, Samir can turn off your mic. Please turn off your mic. Due to virtual short circuit approximation, we now know VA is equal to VB. Okay, from the circuit, VA is equal to VB. So due to virtual short circuit, VA is equal to VB. What is VB? VB we have known. It is V1 into R2 divided by R1 plus R2. And what is VA? VA is also known. It is equal to V output into R1 plus V2 into R2 divided by R1 plus R2. Okay. Now you have a denominator, the common term in the denominator, it can get cancelled out. You can finally write down the result equal to V1 R2 will be equal to V2 R2 plus V output R1. Or you can finally take V output common from this term. Then you will be able to find that V output is equal to R2 by R1 into V1 minus V2. Okay, I have skipped some steps. Now please try to understand that in this term, in this equation, you have V1 minus V2. What are V1 minus V2? V1 is an input. V2 is also input. Okay, so it subtracts two different inputs. Then it amplifies. अगर हम इसको general equation में see the general equation of an amplifier is V output. Say for example, this is equation 1. V output is equal to gain times V input. So this is equation 2. If we compare 1 and 2, comparing equation 1 and equation 2, we will be able to find out gain is equal to closed loop gain. Okay, closed loop gain, which is equal to R2 by R1 here. And V input, it is equal to V1 minus V2. Now see, the input is actually V1 minus V2. That is the subtraction of two inputs. That is why it is known as subtractor or difference amplifier, because it finds the difference between two different inputs, then it amplifies them. Okay, so circuit amplifies the difference of inputs. So please note, the circuit amplifies the difference between inputs, that is V1 minus V2. V1 minus V2. That is why it is known as subtractor also. Subtractor. Of course, using operational amplifier. Operational amplifier. Okay, it is known as a subtractor using operational amplifier.